Here's how you manage networks today, right? We're all familiar with that. It's the Mongolian hordes, right? You just keep throwing people at the problem. That's not the way to do it, but here's why. Because legacy, what we've done is built separate technological silos for managing, right? They're all very device-centric, right? They don't really play together. They come from different vendors. They're all based on complex CLIs. This is not the way to approach the problem. We see it with a product we call Juno Space. Let's provide a single platform under which we can realize the benefits of automated network management and orchestration. Juno Space is a place where we've built some apps, there's a list of them here, so they can all run under a single framework. And when they do, they can do things really interesting, like share data. And when network management apps can share data, now you have the possibility of treating network management as a workflow. Most interesting, because your workflow can then change with the business flow, much more in tune to business goals and objectives. The second thing about it is we build it with open APIs. Because here's what we realized. We're a little company, just $4 billion. We can't build all the network management apps that there are, right? And what we have done is recruited partners. Dell has integrated their management suite with Juno Space. IBM, Netcool, Systems Director. We have a lot of other partners coming on board. And in addition, for our partners, since they're open APIs, if your customer has a particularly unique network management problem, you can build it for them. That means you can charge them, right? Build your own secret sauce with open APIs. The other thing about it is it's not based on CLIs. If you want CLI, you go to Junos. This is based on GUI templates. I think if you look, and what I found out, and our research has shown that 80% of the stuff you do, you could do with a template rather than a CLI or a script. Right? 20% you might need real custom stuff. But I'll give you an example. Configure 5,000 ports in a campus. Now, odds are the few hundred will be the same, and the next few hundred are just slightly different. So you fill out a form, you save it, you bring it up, you fill it out, what are the differences? You save that, right? And it's all done through, click and, right, templates. Once you got all the templates in, bring it up, boom, you can go configure 10,000 ports in a minute. Without complex CLIs, which are prone to fat finger typing problems, which is about 80% of what happens, when you get rid of that, you can make the whole process much more reliable. Here's the kind of results you get using our model. Instead of a legacy 3-tier without fabric, using us, you can expect those kinds of savings in our network designs. And I have traveled the world, guys, and I can tell you these numbers at design time come out almost exactly to these numbers when the network is actually implemented. This is a very accurate tool. Very good selling tool, as a matter of fact. But here's today's reality. 3-tier networks, as we've seen, they're very complex. I've got to build small ones, and to get capacity, I've got to build a lot of them. 2-tier networks are less complex. I can build bigger ones, but I still have a limit of scalability. So, what would be ideal? How about a single network for an entire data center, no matter how big? It will get us to those economies of scale we talked about back in the cloud effect. How do we get there? Well, we transform the network once. Let's just do it again. Let's get to a flat data center fabric. How about a single switch for an entire data center? Very cool stuff. Here's the thing with scaling in 2 tiers, even in 2 tiers. At 1 gig in the access, I have a limit of 6,000 to 9,000 servers, depending on the number of NICs. Where it really starts to get bad is at 10 gig, which is the emerging market today. Why? Because the bandwidth down here at the access layer is 10 gig. It's pushing the core, right? It's approaching what you can talk to the core with. And this starts to become a bottleneck. That's the problem with 2 tiers. What you really have to do is rethink the problem and come out with something that can really scale and still be simple. And that's what QFabric is all about. Simplicity that scales. It has dynamic security, so we can take advantage of the same security services we've been talking about. That gets carried forward. The same edge services we've been talking about, MPLS and VPLS. It's run on Junos, and it's managed by Junos Space, so it has complete architectural capability with prior two-tier model. But here is the key. It creates one big shadow and one big bubble. Let me go back. It's one big bubble and one big shadow. No matter where you move an application, it is always within the shadow of network services, and it is always one hop away from its resources, no matter where. Storage, other applications, network services is one hop away. And if you remember, we said managing the data center is about getting the best application performance, and one of those things is having that application one hop away from its data. It's automatic with QFabric. It doesn't matter where you move it. It achieves that goal. Here's sort of what it looks like. Let me take a second. I'll probably go over about 2 minutes if I do this, but it's important. Here's how QFabric is built. You're all familiar with a chassis switch, right? What it looks like. So keep that in your mind. I've got a box. I have a fabric in the back. I got line cards in the front. Take the line card out, put it at the top of the rack, and bring optics back to the fabric. Right? So line cards at the top of the rack. Nothing but a pure switching fabric in the chassis itself. That's QFabric. Just like a chassis, all the intelligence is now, it's in the line card, I moved it, it's in the top of the rack. The interconnect that you see here in the center does nothing but move data incredibly quickly. As a matter of fact, at 10.2 terabits per second in a single interconnect. That's the fastest damn thing ever built for the network. What happens is all ports are directly connected, just like in a physical chassis switch, to every other port, both physically and logically. All of the intelligence is at the edge in the QF node device. That's the top of rack device. What happens is a packet comes in, it gets decoded once, right? One lookup at the ingress port, heads through the interconnect and out the other side. Period, the end. One lookup, one hop away, always from any port. And how fast? Always under 5 mics. Always, always, always. Always. Except if you get short cables, and then we can get down to 3.7 mics, which means we're up against the speed of light. And I've got the engineer in the next cubicle working on that problem. Got to fix that. But that's QFabric. It's really that easy. Right? Top of rack, QF node, central interconnect. We can talk more if you want me to come back in another time. I'll show you exactly how the whole thing comes apart and works. But it's really cool. But it's really that simple an idea. Not easy to implement, but really conceptually that simple. Scalability up to 6,144 ports. Performance, let's go back to less than 5 mics. Managing the data center is about the best application performance. One hop away, we've showed you that. Low latency, now you're getting the best application performance. It's also low jitter. So it's the best application performance and it's consistent. Helps your customers meet SLAs. It's a single switch. You manage it as a single switch. Runs Junos. It's lossless, it's DCB compliant. I can run fiber channel FCOE over it. And sometime in the future, native fiber channel. Not today, but it's in the spec. Well, yeah. Yeah. It's a gateway and transit. So I can pass it through and into a fiber channel gateway, or it can act as the fiber channel gateway. Either way, it's flexible. But I want to take just 2 slides, because I don't do a lot of product stuff, but it's this QF node device at the edge that's the secret, and it's really interesting. It's a top-of-the-rack mount box. It's 1 RU high, 48 SFP ports, 12 of which are fiber channel capable, 40 gig uplinks. So I got a total of 160 gigs going into the interconnect out of a single top-of-rack switch. That means I can feed it with lots of 10 gig input. Redundant AC power supply. That's the QF node. But here's the interesting part. It's a dual personality. We have a product called the QFX 3500, which is a standalone switch. And notice it looks just like the QF node because it's the same piece of hardware, but with a different piece of software. That's the beauty of Junos. I can take that same box with one set of software, it's the QF node. With a different set of software, it's a regular data center top-of-rack switch. Very low power consumption, 63 ports, less than 900 nanoseconds latency, 1.2 terabits throughput. I'll show you why this is important to understand why this works. So let's talk about how do you get from our legacy networks to QFabric, right? It's a cool thing. So this is basically what things would look like if we're out there. We coexist with Cisco all the time. So I drew this to have, there's a Juniper pod and there's a Cisco pod, and that's all 1 gig hookups, right? In the core, I've got our 8200s here. I got Cat 6 and 7s. That's a typical data center. We coexist with Cisco all the time. Now, your customer has a 10 gig need because QFabric is a 10 gig solution. Here's how we go. First thing we do is we build out a pod for 10 gig. We take our QFX 3500 top-of-rack switches and build it into a standard 2-tier configuration at low scale. And as I keep adding, I can continue to add to the 2-tier until I get to those limits of scale that I showed you earlier, right? Now, what happens when you get to the limit of scale on a 2-tier? You retire, or you take the 8200s and redeploy them, and you move in some interconnects, you reload the 3500s with software, and they magically become the QF node. Same piece of hardware. It doesn't physically move, by the way. It stays at the top of the rack. But logically, it becomes an integral part of it becomes the QF node. This is investment protection. I can build out a standard 2-tier 10 gig configuration, put some new software in it, move in some fast interconnects, and voila, I got QFabric. And then as I scale QFabric, I can even go over and replace the cores for the 1 gigs. A couple of QF nodes can act as the core for the traditional 1 gig pods that aren't going away. So it's a really smooth transition for your customer. It will take him into 40 and 100 gigs because our product is planned into that. And they can do it by accommodating the old architecture and bringing the QFabric architecture to the table. Let's look at it versus the competition. Remember I said best application performance consistently. I've shown you that. Here's the economics. If I put up against Fabric Path, it looks like this. I call this the big pile slide. It's got a big pile of equipment at the bottom. That top one is how, if we were going to build out 6,000 ports, I need 125 top-of-rack devices to get the physical 6,000 ports there. I'd stick in 4 interconnects. That's about the maximum. By the way, that's 40 terabytes of switching power in 4 interconnects. It's huge. And it's L2 and L3, and it's all non-blocking. Thank you, Charlie Kloss. Here's what Fabric Path looks like. A separate L3. And it's not one switch. It's a bunch of switches. As a matter of fact, it's 175 switches. If you look at ours versus theirs, we take a quarter less devices, 56% less power. We have found places we can justify QFabric based on power savings alone, interestingly enough, in large configurations. 75% less floor space. Their latency is 25 to 34 mics. Ours is 5, and it's always 5. It's consistent. 78% fewer links. Optical is not cheap. You just can't consider the cost of the boxes. You have to consider the cost of the whole damn thing. And optics are not cheap when you look at it. Managed devices. That's one single switch at the top. There's 175 at the bottom. That's about a head count of 10. That's not cheap either, is it? And then finally, we have L2 and L3. So I think I've proven best application performance, consistent, and economic. There's nothing like it out there, guys. Nothing.